Hello friends, welcome to my YouTube channel. Today I am going to explain a new concept, a multi-input scenario. This is very interesting topic. Consider two types of input and one type of output. Previously, whatever we have taken the examples, that is a single input and single output. Now I had taken two inputs and one output. The first input is the investment and the second input is the labor charge. And there are two DMUs. DMU1 is beans and DMU2 is corn. And the unit, a type of currency is also same. That is, it is a currency. In investment, first input is also for beans. It is currency. For corns, also currency, and unit is also in thousand. That is in 10,000. For labor charge, type is same, that is currency only, but unit is 1000. For return, type is currency only, but the unit is 10,000. Now we can apply the formula for this equation 2, because earlier we have seen the equation number 1. Now little I have modified the how to determine the efficiency with multiple inputs. Can I extend the formula 1 to efficiency score? In this case the inputs are 2, so this is total input value and output value is 1, so output value is as it is in the numerator, because previously I have seen the formula of efficiency score equal to output value divided by input value, but in this case there are two inputs, so I have taken total input value in the denominator and have given the equation number 2. Now what to do? Because how to add these two inputs? Because first in beans 3 into in the bracket 10,000, the labor charge is 5 into bracket 1000. First we have to convert all the units in same. I will convert this 5 into 10,000 in 10,000 only. At present it is in 5,000, so 0.5 into in the bracket 10,000 and 8 will become 0.8 into 10,000. Then all the units and currencies matching. Now next, how do I compute the input value? It is simply adding the investment and labor charge. Through both are of the same type currency, they have different unit. Investment in 10,000 and labor charge is in 1000. I will convert the input to the same unit, let's say 10,000, and then sum. Yes, previously I have told because we have to convert into the same unit. So next slide, previous slide, again I will explain you, because 3 is there, 3 is in 10,000 and this is 5. If 5 is also in 10,000, 0.5 in 10,000 I have to write, and 2 is also in already is in 10,000 in case of corn. And if I convert this 1000 into 10,000 means 0.8 in the bracket 10,000. That is here clearly written. So total input value for beans is 3.5 in 10,000 and total input value for corn is 2.8 in 10,000. Now all the things are matching. Now use the formula, compute the efficiency score using 2 gives. Now beans value how much we got, that is 0.9428, and corns we have got that is 0.8036. Beans emerges as the efficient DMU. Oh, that's good. Previously, again I will explain you, I have converted this 1000 in 10,000 and this is 8 also, 8 unit also in 10,000, so 0.5 it came and 0.8 it came. So next I have already explained this one. Next slide. Now farmer is asking a data analyst, hey data analyst, Why treat both inputs equally in efficiency calculation? My observation shows that some worker contribution minimum, and even without them my profit is unlikely affected. This suggests me my investment has a greater impact on returns than labor cost. Please prioritize my investment over labor charges. Then the data analyst speaks to the farmer. Hey farmer, should I prioritize your investment just because you observed lower labor contribution? Your observation might be flawed. What if these workers, despite working less, accomplished the most productive task? Efficiency must be calculated objectively, not based on a personal preferences to avoid the bias. Fine. Even if we agree labor contribution is smaller, it implies labor charges should carry less weightage than the investment. But how much less? Arbitrary weight should also be compromises fairness. Then actually previously what in previous slide now again I will explain you. I Because the investment and labor we have given 100% weightage, so directly we have added that is 3 and zero point 0.5, that is 3.5, means for investment also we have given 100% weightage, and for labor charge also we have given 100% weightage. But the farmer is observing that the investment whatever he has invested, that is okay, but the labor are not working effectively, or he is thinking that if I minimize the cost of labor, then also I will get the profit. He is thinking that the role of labor is not affecting his profit, because he is thinking that without weight giving so much preference to the labor also, he may get the profit. Then scientist he will think that why are you thinking in that way, because the timing is for labor is 10 to evening 5. It might be starting 4 hours he the labor is not worked effectively, but afternoon or evening the labor worked effectively. Then this is some conservation is going on between a farmer and a data analyst. But because three investment is in 3 unit, that is 30,000, and labor charges is 0.5. If we both are adding 3 plus 0.5 means we are giving both equal importance, but the farmer is telling that I will not give the equal importance to the labor, I am giving the less percentage or less weightage. Next slides. Let me give 91 percentage weightage to the investment and a 9% weightage to the labor charges, and the result just now labor is thinking that that farmer is thinking that I am giving the 91 percentage to the investment, and only I will give 9 percentage weightage to the labor, because if I am giving 9 percentage also I'm happy with my profit. And we will see the result. After the calculation, a corn will emerges the efficient TMU. The calculation is very simple. You can see here total input value of beans 3 is as it is, and here due to 91% multiplied by 0.91 plus 0.5 into this for 9 multiplied by 0.09, the answer we have got is 2.775, and the total input for corn 1.892. Next, let me give 90% weightage to the investment and 10% weightage to the labor charge. What will be the result? Now the story changes, because just 1% I have decreased, then beans emerges as the efficient. See the calculation previously, because total input value of beans equals to 3 into 0.9, because we have given 90 percentage weightage, and 0.1 because we have given 10% weightage. After the calculation and using the formula of efficiency score, using the equation 2, Here also using the equation 2. In the case 91 percentage corn is efficient, but in the case 90 percentage beans is efficient. So how we can give the weightage? Because if we are giving 100% weightage, then farmer is unhappy. But if someone give 91%, 91 weightage to the investment and 9% weightage to the labor, corn is efficient. If someone is giving 90 percentage weightage to the investment and 10% weightage to the labor, beans is efficient, then it is very confusing. So how to choose which weight is correct? Now it is very difficult process, because someone comes and he will give some weightage, and some other person will comes and he will give some weightage, but we don't know now which is the correct weightage they are giving. Because if you give 100% weightage, then also there is a problem. If you give less percentage, that like 91 and 9 percentage, then is also we are getting a different result, just for the variation of 1 percentage. Okay, so next you see here, so I trusted the former observation as assigned the lower weight labor charges in the first trial, that is 91% and 9%, and in the second trial 9%, 90% and 10% investment and labor charge. But this leads to the contradictory result. Corn will were the efficient in first trial and beans will in the second trial. This highlights the flaws of subjective weights assignments. My earlier analysis by giving equal weight seems fair, but what if the former observation is really correct? So if farmer is observing really, because he is observing that I will not give the equal importance to the labor. If he is thinking correctly, then how much weightage we should give for labor? 90, 91, 92? It is, we don't know for what weight we are getting the profit. Then my earlier approach would be inaccurate. Hence neither I myself nor based on the former observations weight should be assigned. Now it is very difficult now to give the weight, because for 100% also there is a problem, for 90, 91% also, because we are getting a different result. Okay, if we fix for 100% means farmer is unhappy, because he is telling that my observation for the labor is I am not satisfied. If I decrease the amount which I am paying for labor, then also I am very happy. If 10 laborers are working in my this in garden, or in my in garden 1 or garden 2, I am getting, if I less the labor number, then also I am getting the same profit. If some working in some my agriculture also, if 10 laborers are working, if instead of 10 labor, if labor work will be 5 also, I am very happy in my agriculture, I will get the profit. Example I am giving, it depends upon the labor where they are working. Next, instead we need to design a model that objectively determines the wage for investment and labor charges, ensuring unbiased, fair and consistent efficiency calculation acceptable to all. So anyway, if there is more than one input and more than one output, then we can use the equation number 3. Now a doubt regarding the values of the weight. What type of value we have to give? That is in the open interval 0, plus infinity. Additionally, the model must ensure it is unreasonable to accept the identical weights for inputs across both crops. Yeah, another doubt. What if both inputs are not of the same type? Consider this example. Here input land area is 2 acre and investment is in currency, and unit is also in 10,000. In corn also the input land area is in currency and the investment is in 10,000. Then what to do? Because the first para tells us that it is not necessary to give the equal weightage to for DMU1 and for DMU2. We may give different weightages. What if the type is not same? What if the unit is not same? So it is very difficult to get the result na. So a common sense tells that we need to compute the equivalent monetary value of land area or the equivalent land area for the investment before computing the weightage of the some inputs, and hence to calculate the efficiency score of DMUs. The same principle applies to multiple output as well. However, we need a model that take care of all this conversion by itself. Now if we had a model that will take care of automatically type and this unit and everything, and weight also he is giving by its own, and everyone should accept that result. If we built that type of model, then there is solution to all our problems, because we are facing the problem. Because if we give the equal importance that investment and labor charges, the farmer is thinking that some labors are not working properly in my agriculture or in my garden. He's thinking that instead of 10 labor I will if 5 members is working, then that is sufficient. So if weightage is varying, because he is not happy with the 10 farmer, if he give less weightage means he will satisfied with 3 farmer, 3 labor also. So what to do if 90% weight is given and 91% weight is given? The result is different. Sometimes corn is efficient and sometimes beans is efficient. What to do? Because sometimes we have to convert the unit, and sometimes we have to see which type of currency is the same type. It if what if there is not a same type? In this example, 2 acre is there. How to convert this acre into currency? Acre is also just example. I am having 2 acre. Acre is also there is a currency. If after I am selling that one, I will get the money. I will convert that one into money, but it is very difficult how to convert and everything. Instead of all these problems, if I had a model which take care of all these things, conversion of unit also, a type of type, that is it is a currency or a quantity, and it should give the weight by itself own, and everyone should accept that one. There is no confusion at all, because if person is giving the weight means someone tell that no, no, you are giving a wrong weightage. If some other person is giving the weight, it means no, no, you are giving a wrong weightage. But if the model gives the weight and it will calculate the weight automatically, then everyone should accept it. Can we build such a model? Yes. Now the birth of CCR model comes, and these models will help if there are number of input and the number of output. Because in case of single input and single output, we can use the formula efficiency, and I told you in which condition we have to use the formula, that is same type and after unit conversion everything. But as input increases, output increases, then this formula won't work. Because why it won't work? Because weightage, percentage of weight we have to give. Okay, example you can see here. Example you can see here previously. Now investment is 3 and labor charge is 0.5. After I'm converting in this 10,000. Okay, so 3.5 means I am giving labor for labor also 100% weightage, and for investment also 100% weightage. If I am giving less percentage means I am getting the different result. You can see here I'm getting the different result. I am giving 91 percentage weightage to the investment and 9% weightage to the labor. I am getting corn is the efficient. If I am giving 90% weightage to the investment and 10% weightage to the labor, I am getting beans has the efficient. So there are again problem is arising. If I give equal importance, then also problem. If I giving different weight, means how much different weight I am giving. If I give 93, and if I give some different weight to labor, then also it is problem. Because if person gives, means how can we believe that the person is giving a right weightage? Instead, if a model is there, that model take care of all those things, conversions. If type is same or not, unit conversion, and the model will give automatic its own weightage. Whatever the answer will come, efficient or inefficient, we have to accept it. There is no discussion at all. Can we build such a model? Yes, that model is nothing but a CCR model in the year 1978. Because if the number of input and the number of output increases, the efficiency formula won't work. Because why it won't work? Because in this example, I am adding investment plus labor charge, I am getting 3.5. Then I am giving equal importance. If I am not giving equal importance, you are seeing that is I am giving 91 percentage weight to the investment and 9 percentage weight to the labor. I am getting the corn as the efficient. I am giving 90% weight to the investment and 10% weight to the labor. I am getting beans is the efficient. Then what to do? How to overcome this problem? Then three scientists has discovered a model called CCR model. Let me go to the CCR model. Fair efficiency calculation, the CCR model. Year 1978, Charnes, Cooper and Rhodes developed a mathematical rigorous approach to compute objective input-output weights, derive bias-free efficiency score, enable fair DMO comparisons. So these three great scientists has discovered or invited this CCR model. This is a very important model. Now the research starts, and this type of research is used in economics for policy making, and used in operation research and mathematics and in management also. So thank you for your valuable time, and next I will explain you what is the CCR model. Thank you friends for your patience. If you have any doubt, you can comment me. Thank you so much.